Hey there, I am going to show you today how to design a plug or mold from a part that you want to make into carbon fiber. Using SolidWorks as my modeling software, but you can do this in Fusion or other softwares. Most of the functions are pretty similar, so you should be able to find similar ways to do it. Let's just jump right in. This is a part that has been designed to be made out of carbon fiber. I can show you that by doing a draft analysis quickly on here. You can see that this part has good draft, at least 3 degrees on all edges, and has no undercut geometry. Now, if I'm making this as a plug, I'm interested in looking at it from this direction. However, if I'm interested in looking at it as a mold, I do need to flip it over and look at it from a cavity direction. In both cases, it's going to be correct and good to go. So, with that confirmed, I can proceed to the next step. So, we are going to do our offset surface. Going into offset, we can go to here. I like to filter by faces, get ourselves so we can see the whole top, and simply select all faces. This may have selected a couple faces we don't want, such as the insides of these holes, so we can come through and deselect these so that we don't end up with any weird features in our part. So those 4 holes and probably 4 more on this side got selected, and sure enough, my offset is currently set to 0.1 inches, which is nice for seeing what you've selected, but we're going to want to make that 0. In SolidWorks, you can't actually select a 0 offset, so just make it a very small number. And you can see the offset now is basically the same shape. I approve that, and you can see now that I have a solid body and a surface body. I like to change the solid body, which is my original part. I like to change the appearance on it to, let's just call it red or some other color that's going to be a little more obvious and contrasting to the gray. So with that, I will hide the solid body, and we are left with what will become our plug or mold body. We're going to first want to go ahead and block off any of these cutout surfaces that aren't going to be included in our mold. These will be cut out after we finish making our part. So a simple filled surface will do it for the most part, especially on holes like these ones. So just select the hole for your filled surface, if it will let you. There we go. And I like to fix up the boundary and merge the result. You will see that hole disappear. We'll do this a couple more times. Bear with me while we click through all of the holes on this part. Okay, the last cutout to eliminate is this slot on the top. A filled surface should do the trick here as well. So let's just select all of these edges and make sure we get a nice filled, smooth tangent surface. Once again, we'll merge the result and hide it. So all the cutouts are gone. I'm going to leave these cutouts in the side because I want to be able to index them a little more easily when I trim this. So the next step is to actually extend all surfaces tangentially by 1/4 of an inch. This is going to give us extra material on our part. There's an extend surface feature that will do this quite well, usually. Although I do like to state that sometimes features will not work. You can try it maybe on a different location, see if that extend feature will work here. You can see it's coming up with a lot of weird looking surfaces that aren't going to work for us. But don't worry, there's other options. There's ruled surface, which we can do tangent to the surface as well. 0.25 inches tangent on these guys. Looks like we'll get some of these surfaces to work and some that won't work, which is good. Able to show you some other tricks to extend these surfaces when they don't want to extend on their own. But in general, this ruled surface feature in SolidWorks is a great option for you. And looks like now they all have worked. We can also even see if we can get it to extend within here. And it looks like that breaks it. So let's go ahead and exclude that and just do the easy surfaces for now. That looks good. Okay, I do want a 1/4 inch extension inside of these cutouts as well. So let's try ruled surface, but once again, just with them does not want to work. Okay, let's try an extend surface inside of here. Also doesn't work. Okay, so that's fine. We're just gonna have to get a little more creative. So we can probably do a swept surface around here. Would be a pretty simple way to do it. So we can go ahead and just sketch on this surface, draw ourselves a 1/4 inch line, dimension that. There we go. And now I'll go ahead and do a 3D sketch. This is very common in creating flanges and features in a solid or surface. Let's do a 3D sketch, convert entities. Go ahead and grab the parts that you want. So in this case, all of these. Oops. Let's try that again. 3D sketch, convert entities. There we have it. And delete that one. Put that in there. Okay. Finish up that sketch. And let's go back to our surfaces and do a swept surface. We can do a sketch profile as our surface, and we're going to sweep it along our 3D sketch here. And there you have it. You get basically what we wanted there. And we can accept that. We do have a couple little corners to fill in. Simple boundary surface will do great here. Select one for direction 1 and select the other for direction 2. Should get you a nice square filled. And one more boundary surface here, direction 2, and we're all filled in. We do need to do the same thing on the other side. Is a different shape. We can't simply mirror it, so we will just need to step through the same process, although it is a flat surface this time. So let's go ahead and check and see if one of our other features might work for this. And if you look at that, a nice ruled surface does the trick perfectly. Nice and easy to fill it all in. Okay, so now we've extended our surface. So you'll see now if we show our part again inside of here, our mold now extends beyond it, which is going to be good for machining or even 3D printing, where you might potentially have loss of detail in the corners. We know we're going to be able to capture our entire part. So let's hide the part again. We do have a lot of surface bodies. It is smart to go ahead and knit those all together. Check your gap control, merge the entities, and make sure that everybody is happy. So that looks good. So now let's go ahead and confirm our pull direction on this part. We already did a draft analysis, but I do know that I'm going to be pulling vertically on here. So I want to go ahead now and create flanges that are perpendicular to that pull direction. So surfaces again, the ruled surface feature is great for this, and we can actually make it perpendicular to a vector. So we can select this top plane and say that we want our surfaces to be perpendicular to this. And now 6 inches is your ideal amount of flange for a part, for at least for a plug. And this allows for, once you make your fiberglass mold, that you could actually lose a couple inches and get you down closer to 4 or 5 and you'll still be alright. So let's go with 6 for now. If we are going straight to a mold, we definitely could reduce this down to the 4 inches or even less if you are going for a machined aluminum tool that you're not going to actually pull vacuum on. Maybe it's going to go into a press. But you can see I can select around these edges and it's going to maintain perpendicular. And I do see a couple weird things happening here, which is another good opportunity to see what we got going here. So work our way around and get the last edges. This side will probably work out nicer than the other, once again, just because it's a flat surface versus the other side has some curvature to it, which when working in surfaces you're bound to find. Okay, so it looks like we have a pretty nice flange going around our part here. Let's see if it'll accept it. It does, although now looking at this one you can see we have something really weird going on here. And that's pretty normal that you're going to run into an area like that when you have a complex feature. So you can go ahead and just delete that face, the one that is not working, and we can just patch it up manually. This one, it looks close enough, but let's go ahead and patch it with a boundary surface. You can use the 2 outer walls as your direction 1, and then you can use the arc as your direction 2, and that should create a nice swept profile. Looks a lot nicer. Alright, once again let's go back and knit our surfaces together to make sure that we are all merging correctly. If it doesn't merge correctly, you'll probably have to go and find what's wrong, and usually it's an overlapping surface or some sort of vertex points that's not coming together just right. So as we look at this part right now, we are looking at it as a plug, right? It is a positive male feature for making our part. If I flip it over, we are now looking at it as a mold, a negative feature. So again, if I'm going to be machining this directly out of aluminum, then I could go straight to a mold like this. But most likely for a part like this, I would be machining a foam plug that would look something like this. So let's go ahead and convert this into a solid body, just so we can see what that looks like in that process. So I would like to put 1 inch below our bottom surface. Let's add ourselves a flange plane, and let's flip that and change it to a direction. Oops, close back out of that. Let's go off of here and say 1 inch offset downwards will be the base plane for our part. And just extend this surface, this plane out a little bit. So we now, pretty simple way to convert this into a solid. You could thicken it, of course, but that's just going to get you a thin featured part. I like to go ahead and draw on this plane that I've just created. You can go ahead and convert the entities of your entire outline here and bring them all into this sketch, and it should mimic the outline perfectly. So let's grab these. There we have it. Let's make sure everything worked out. We do have a couple funny looking things along here, and probably the same over here. You can see there's some points that aren't lining up to each other quite right as well. So actually let me take a step back and show you another way to do this. You can just go ahead and draw a square on here. You don't really need to have those rounded corners anyways. So we can go ahead and from our center point draw ourselves a rectangle, and then in your surfaces you can trim the surface and just remove these outer sections. Just simplify the mold quite a bit. So now you have a square shape. From there you can draw again on this same plane, but instead of trying to capture everything, we can just do a rectangle from corner to corner, like so. And then I like to do a surface extrude. It doesn't need to be quite that tall by any means, but what we can do is offset it. And let's go ahead and just offset it by 6 inches. Flip the direction back down and go back down 6 inches. So we're back to where we started, but we're going to add an end cap to it, so it puts a surface on the bottom as well, and accept that. We can then trim away all the excess on the top. We'll use our main flange, and we will remove the top. What you should be left with now is a closed cavity. SolidWorks doesn't recognize it yet. It still thinks it's two solid or surface bodies, but we can knit them together, and now the Create Solid feature should be available for selection, and you can turn this into a solid body. Your original part should still be in the model, and it should be under the surface here, not visible, which is correct. We know that our part, we have extra material around all the edges, so we won't run into any issues. If we were to CNC this plug right now, and we came down these walls with your ball end mill, you're going to end up with some fillets in the bottom. And so knowing that we use a 1/4 inch ball end mill for finishing, this is going to be 1/8 of an inch all the way around, which once again we can confirm that this our part will not be lost because of the fillet along the bottom edge. And you don't actually want to have sharp 90-degree angles anyways, so having that fillet there is going to be better in the long run as well. So we could go ahead and continue putting these fillets in all the way around our part if we'd like, just to imitate what it's going to be like once we do machine this mold, or this plug, excuse me. So now we have our plug. I would say this is complete. There are instances when we might want to instead form a solid mold if we're going to just send this off to 3D hubs and have them machine an aluminum mold for us. So I can pretty quickly, even just with deleting some surfaces, I can get rid of this base and my walls again, and we can go back to where we were. And once again, here we are looking at our mold, but if we want to turn this into a solid, all we need to do is create ourselves a new surface. So we can do a plane. If we do it off the lowest point here, it's not quite the lowest point, but that's okay. We can then just offset a second plane from that, and let's just give ourselves 1 inch of space on the bottom of our mold. We'll do the same thing we did last time, sketch ourselves a rectangle edge to edge of our flange and do a surface extrude. Doing the same trick as last time, we'll offset it by those 6 inches in the other direction, have it come back down to 6 inches, and we'll put the end cap on. And finally trim the surface using our flange again and removing the excess from the top, and do a final knit to create a solid. There we are. We can hide some planes here, and now we have a mold that is a cavity, and if we show our part again, you will be able to see it within your mold, and we can see that we are nice and removed from our trim edges. So in the case of us, we have a 1/4 inch trim bit that we would just run around the flange, and it would cut out all of these items. We would still need to come back and add these drill holes as well as this slot. We could score this mark in the mold or in the plug, and then we'd probably make ourselves a simple drill guide for getting the holes in the ends. But that about covers it. That is how you can create a plug or a mold in a SolidWorks or any other similar CAD software.